Hey everybody, today we're going to be talking about logarithms, the laws of logarithms. You may have in the past put some logarithms into calculators and you may have noticed some patterns. Now we're just going to kind of lay it out explicitly, which means lay it out with our actual equations or as a statement and express what of these laws are. So we've got let's start with log of A plus log of b. Now, keep in mind first, before we go anywhere, that when we have logarithms and we don't put a base here, we've got no base, that means that it's base 10. We have a base 10 system, so we always are going to assume that that is base 10. So if we have log of a plus log of b, that is going to be the same thing as log of a times b. Now, you notice I put these in parentheses. That's because we are taking the product of A and B first. So we're multiplying those two things together first, and that result is what we're then taking the logarithm of over here. So you have to make sure you multiply those first. So that's why we did the parentheses. Next one, log of A minus log of B is going to be equal to log of A over B. Very similar to some of our exponential rules, which should make sense because logarithms are the inverses of our exponentials. And the second to last one that we're going to do is n times log of A is going to be the same thing as log of A to the nth power. So we're just taking it and moving it to the outside there. The last thing that I'm gonna put up here is something that we have probably talked about, or that you've seen before maybe, if you've gotten to this point in logarithms, and that's kind of the logarithmic identity. And that is if you have, I'm going to use little letters here, log of little a to base A to, let's say, the x power. If you've got a log of a base, of a certain base, and then your result is that same base to some power, these things all cancel out and you're left with just your power, just your exponential. And in a similar way, if you've got, if you have A and you have it to the power of, if somehow up in your exponential and up in your index, you got log of base A, be that 10 or 2 or whatever that base is, and that is of x. So that means you've got your base, or your base is A, and then you're taking it to the log base A, and then you have the x up there as your result, then that is going to just leave you with x. So essentially what happens in both of these two things is your log and your base cancel each other out. All these things are going to become important as we go through and look at a few simplifications. That's what we're just going to kind of look through some examples here and try and simplify a few problems so you can kind of get used to seeing what happens here. So let's start with log of 5, or again base 10, plus log of 3. Well, you're probably going to see this one like, oh, that's really easy. That's going to be log of 5 times 3, which is log of 15. And if you were to punch these into your calculator, you would recognize that that is the case. So if you took log of 5 and then you added log of 3, you would see that it would be the same thing as log of 15. So the next one, just to kind of get a couple examples out here. Let's look at something that's maybe a little bit more complicated. Let's do log of 2 log of 7 minus 3 log of 2. All right, so our instinct might be, let's kind of separate these so we know that they're different. Your instincts might be to start trying to divide by 2 and all that, but we can't do that because we don't have an equal sign. All we're doing is we're simplifying, so we're just rewriting this equation, or this expression, I'm sorry. Yes, we are putting an equal sign here because we're just showing that this statement equals the next statement, but that's not something that we can divide both sides by anything or anything like that. Okay, so we're going to start by getting our indexes. So we're going to start by moving this thing into the index using our third property, our third law up above. So we're going to have log of 7 squared, so I just move that up to the top there, minus log of 2 cubed, right? So this 2 moved over to the 7, and this 3 moved up as an index of the 2. Now, we just simplify these. We know that log of 7, whoop, I'm out of space here. Let me get myself some more space real quick, so that way we can have enough space here. That will probably help. All right, so log of 7 squared, let's just do this. We know we've got a subtraction there, so we've got log of 7 squared over 2 cubed. All right, our whole point is to simplify, so we're not quite simplified yet. So we'll take our log of what's 7 squared, well that's 49, and what's 2 cubed, 2 times 2 is 4, times 2 is 8, log of 49 over 8. And because these were both prime numbers, we can't simplify any further there. We're kind of at that point. All right, let's look at another one here. Let's see if I can get myself some more space. There we go. Extend this up a little bit. All right. And so that way you can kind of see what we've done here in the past. Okay, so just a couple, 2, 3 more problems. Let's look at, we'll use a different color to kind of separate us out here. Let's simplify log, so we're going to simplify this. We're going to simplify log of 8 over log of 4. All right, well, that seems kind of weird. All right, we haven't really done one like this, but let's see. All right, so log of 8, I know that's going to be, I can rewrite that 8 in the same base. And you might recognize that the 8 and the 4, they have the same base. If you look at just those two numbers, if you ignore the logs, the 8 and the 4 have the same base of 2. So let's try starting there. So log of 2 cubed over log of 2 squared, right? I just changed the 4 into 2 squared. I changed the 8 into 2 cubed. Okay, well, using our laws of logarithms, we're going to move that exponent of 3 out to the front, log 2, and we're going to move that exponent of 2 out to the front. So we've got 2 log 2. Now, how can we simplify from here? Well, if you were to punch anything into your calculator, you would know that you have to take log of 2 is one whole piece. So you want to think of this as one whole thing. That's like a variable almost. You cannot separate this logarithm and what the result is, log of 2. So you can't separate those two pieces from each other. But this is saying in the numerator 3 times whatever log of 2 is. In the denominator, it's 2 times whatever that log of 2 is. So this thing is our common piece, and we can cancel those out, and we're left with just 3 over 2. People are going to have some trouble with that one. They're going to want to simplify or cancel out those 2's in your logarithms, but you have to keep in mind that you have to keep that as one whole chunk. One other example that you might see, and this is going to be kind of almost like a little proof, if you will, and that is going to be, we want to show that, let's use our red here, show that, what are we going to show? We are going to show that log of 500 equals 3 minus log of 2. All right, so when this says that we need to show something, that means we're basically going to work one side or the other to get it to look like the opposite. So I'm going to start maybe by 3 minus log of 2. So I need to get that thing to look like log 500. Or the other way around. I could go log 500 and I could work to get that thing to look like 3 minus log of 2. And actually, I think that's the route I'm going to go. I'm gonna look at this piece here, and I'm going to look to see how can I make log of 500 the same thing as 3 minus log of 2. All right, so first thing I'm going to do is I'm going to think about the properties of these things. So I know that I need to end up with a log of 2 over here. So that means and a subtraction. So I've got a subtraction and I've got a log of 2. So that means at some point I'm going to need to make this thing a division problem. So I'm going to start by looking at what can I make 500, what can I do with that to make it a division problem where I'm going to end up with log of 2. Well, let's see. I guess we could try two different things. We could try 500 divided by 2, so then we'd have 250, but I don't know any cubed numbers that get me to 250, right? Because 500 divided by 2, that would work. I could have log of 500 minus, sorry, no, I couldn't do that. I couldn't do that because that would be changing this problem. So I need to write an equivalent statement. I need to write an equivalent statement. So I'm going to write 1,000 divided by 2. And this is what I mean by that equivalent statement. 1,000 divided by 2 is the same thing as 500. So I have to make that thing equal. Every step I make has to be equal. When I did the 500 divided by 2 just a second ago, that would be changing it to log 250. And we can't do that. So we're going to do log 1,000 divided by 2. Same thing. That's the same thing as this. These two are equivalent. Okay? So now, how can we break that down? Well, that log of 1,000 divided by 2, we know that's going to be log of 1,000 minus log of 2. All right? Now, all right, this should start rolling for us now. We need this thing to be 3. So what is 1,000? What is that a cubed number of? Right? Well, and how do I know that I need to get a cubed number of that? Well, let's see. 10 cubed, so log of 10 cubed minus log of 2. All right, how did I come up with that? Well, I know I'm in the base 10 system because I'm not writing any bases here, right? So that means that I'm in log of base 10. So if I want to get a 3 left, that means my logarithm has to cancel out. So I want to have it become log of base 10 of 10 cubed. So I know that these things will cancel out. So this all cancels, and we're left with 3 minus log of 2, which is what we had up top. That thing matches this up here. So we have shown that log of 500 equals 3 minus log of 2. So there's going to be a few things where you see problems like that. Those are going to take some practice. They're not going to be super easy right from the start. The first few examples where you're just practicing the logs of logarithms, those things are going to be okay. But this last one, that's going to take some thinking. So you might have to spend a little bit more time on problems like that. But hopefully that kind of gives you an introduction to what logarithms look like. Next time we will look at substitution with logarithms and how that works out, simplifying and substituting. So good luck with anything that you are working on with this.